Hello everyone, how's everybody doing? I hope better than me. I'm still catching up on my health. I've had a little bit of a cold for the last couple of weeks, congestion, but apparently I'm getting over it. I've had been in Malaysia, Singapore, Sweden, back to Germany, and in all places I had rain follow me, and that's part of the problem. The other part of the problem is for sure old age. I guess it's harder to shake these things off when you get older. Anyways, what do I want to talk about today? I want to talk about um, the gravity of some of the comments. We had some comments, and they're pretty grave. um, Best way to start the lecture today is looking at a skeptic, one of the first skeptics, I guess, right? Least documented skeptics. And he lived in the 10th century. His name was Al-Hazen. He was an Arab. And I'm going to quote him, which I'll call the principle of skepticism. Now, keep in mind that skepticism for skepticism's sake is not good. You don't want to just at all times be a devil's advocate and say, well, I don't believe, I don't buy that, and because when you don't buy a theory, it means you bought another one. Everybody's got his own religion. Everybody's got his own beliefs, his opinions, and whatever opinion you have, that's your religion. So everybody's got a religion, one way or the other. Everybody's got opinions and way of thinking. Some of them because of how they were educated, some because of the way your brain works. Got a lot to do with all these different factors. Anyways, Al Hazen said something interesting, and I'm just going to put this up here. All right. And he said, the seeker of the truth is not one who studies the writings of the ancients and puts trusts in them, but rather the one who suspects his faith in them and questions what he gathers from them. The duty of the man who investigates the writings of scientists is learning the truth. If learning the truth is his goal, is to make himself an enemy of all that he reads, and applying his mind to the core and margins of its content, attack it from every side. So what is Al Hazen telling us? He says, look, the first thing you got to do whenever you read something, whenever you got a theory you like, is become an enemy of it and attack it every which way you can. Now, how's that for a principle of skepticism? Now, that's very easy to say and very hard to do. Why? Because we already have certain notions of what we think should be right in our minds. And what Al Hazen is saying, you should get on the other side of the fence and criticize yourself. Partly, I would say, because it's better for you to criticize yourself than someone else coming and criticize you, like in public. Before you you go out there, you really want to make sure you know what you're saying, and that you know all the angles, all the pitfalls, etc. Because otherwise, you're going to be surprised. Someone who said, "Oh, how about this?" and say, "Oh, I didn't even think about that." So it's best to criticize your own theory and be the enemy of your own theory. That's a good place to start. And of course, if you don't do it, someone else will, for sure. Someone else will criticize your theory. Okay, no matter how good it is, no matter how truthful it is, etc. Someone will criticize it, and that's the other way of subjecting your theory to scrutiny. And it doesn't mean that because someone criticizes your theory that what they're saying is correct or even rational. Okay, someone might attack your theory, and you can tell that the person's not qualified, doesn't understand even the foundations, the basics. And so, no, you don't want to listen to that person because you're just wasting your time and his time. Now, it's nice to have someone who understands your theory, who has taken the trouble of reading it and understanding it. And then, yes, you can butt heads. He might say, you know, I don't like this, or I think this is where you're not doing it right, or I think this is irrational here, you know. Only then can you have a meaningful discussion. But if someone doesn't understand your theory and comes in there and starts criticizing it, you know, it ends up being all emotion and very little intelligence. It's just an emotional response. Oh, I don't like your theory because of this, this, and this. Listen to my theory. Did you understand my theory? No, I don't understand it, but, you know, here's my theory. No, it doesn't work that way. If you're going to criticize someone, the first step is to try to understand the theory that he's proposing, the mechanism, as I say, the causes that he's offering. And then, yes, you can deal with it intelligently. And I had a couple of visitors, and they didn't do a good job of understanding. They immediately went into the emotional mode. Saying, I don't like your theory, I think it's garbage, blah, 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 and here's my theory. Some of them didn't even put their own theory. They just went ahead and said, it just stinks. And did they understand the theory? Well, let's find out. Here's one of the comments I got, and you can. I'll let you figure it out for yourself. Okay, this all comes in there, and he says, "If I tie a rope between my TV and my bed, it doesn't pull the TV to the bed. Just tying a rope doesn't do anything. What causes the pull? Each atom in the apple is also tied to 50 octillion atoms throughout the universe. Why doesn't the apple get pulled up towards Andromeda Galaxy instead of the Earth? The strength of the pull is affected by distance. How does it vary by distance?" Okay? So obviously this, and he goes on ranting about, you know, how lousy my theory is, etc., okay? But you can see this person has not even taken the trouble to understand the theory. He hasn't done any research. He hasn't listened to it. I mean, I do have lots of videos and papers that I've written, and there's Quora articles. I mean, there's enough information out there for you to more or less get a good picture of what the theory is about, especially regarding gravity. And he hasn't taken the trouble. He's just an emotional reaction. He said, you know, I don't understand how you produce pull with a rope. Your theory stinks. Okay? So, for those few people who still have an open mind, okay, and you are willing to explore, I'm not talking about convincing you, persuading you, none of that. I'm here to make you understand my theory. I want you to understand it before one of us dies. The only issue here is whether you understand the theory. Okay? Then what you take home with you and decide on your own, that's your personal business. You know, that's your personal opinion, your personal religion. Here we're just interested in finding out whether you understood the theory. And obviously this fellow did not understand it. He just went to emotional mode, okay? So let's see if we can understand it. I'm going to start with, not me, I'm going to start with a mathematical physicist, okay? This is on the other side of the fence from me, okay? So it's not that I'm bringing a friend over here saying, you know, this guy's going to vouch for my stuff. Nothing like that, not at all, okay? I'm going to bring a guy who's a mathematical physicist, and he's going to tell it to you like it is, okay? And this is a professor. He's from Berkeley, okay? He's a mathematical physicist. I call him mathematician. Not a friend of mine. He probably doesn't even know about the rope model, okay? So this is what he says. Look, listen to him. Okay? Not to me. Listen to him, okay? He's got authority. He's got, you know, the backing of the entire establishment, okay? So you're not listening to me now. You're listening to someone else tell you what he thinks of gravity, okay? Listen carefully to what he says, okay? Here it is. Okay, and here he is. His name is Richard Muller. And he says, so, for example, if you have the Earth, there's a big mass here, right? He's referring to that big M on the board, and that's the Earth. And you have you with your little mass here. That's you on top of the Earth, that little man there sitting on the Earth. Every atom on earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. Maybe you should read that or listen to that one more time. I'll just get the second part there. Every atom on earth is pulling on every atom of you. You're also pulling on it. The amazing thing about gravity is that it goes right through things. That's the description of gravity. Every atom is pulling on you, you're pulling on it. And we can extrapolate that to the entire universe. We don't have to leave it, here on Earth. We can say every atom in the universe is pulling on you. Why? Because every atom of the sun is pulling on every atom of the earth. Every atom of the earth is pulling on every atom of the sun. Every atom of the sun is pulling on every atom of Jupiter, etc., etc. Every atom in the universe is pulling on every atom of the universe, and every atom of the universe is pulling on the other guy. You got to sit back and really think about what that means. It means that if you have an atom in the middle of the wall of your house, just look to the side, you'll see a wall, right? But you see the surface of the wall. And what this fellow is saying, he's saying if you go to the middle of the wall, you go, a few centimeters inside the wall, that atom there in the center, trapped by all these other atoms of cement or whatever, your brick, right? That atom is also pulling on you, and you're pulling on it right through the other atoms. We got to explain that. That's what we have as a description of gravity, okay? So that's what we have to explain, how every atom pulls on you. And obviously you can't do it with space-time because space-time is a mass. They just, kind of smear it out and say, well, mass, whatever mass is, right? They work with math. They say mass bends space-time, and space-time is geometry, and the other object rolls down the depression, okay? But they don't tell you, in space-time theory, in general relativity, they don't tell you how each atom is pulling on the other atom. There's no mathematical description of that. All there is a field equation that says, look, here we have this field, whatever a field is, right? And it bends space-time, which is, again, you got to think of it as a field, as some kind of unimaginable medium. And that's gravity, geometry, the bending of space-time. So they're not focusing on what each atom does and how it does it. Okay, that's not what general relativity does. And of course, quantum mechanics still doesn't have a theory of gravity. So no one in mathematical physics today can explain to you a mechanism of how one atom pulls on another atom and the second atom pulls on the first one. And that's what we have to explain. As you can see, Richard Muller, professor at Berkeley, says that's the description of gravity. That's what we have to explain. Okay? So that's the starting point. Now, you may not like it, might destroy your religion, but all I can ask you is to keep an open mind. Keep an open mind. Forget about what they taught to you in high school or college or whatever, because here we're going to have obviously a different version of that, and it doesn't mean you have to believe it. It means we're here just for you to understand it. Keep an open mind, okay? Try to think out of the box, meaning thinking outside of what they taught you. Apply Alhazen to yourself. Be a critic of yourself, of what you know for sure, of what you've proven to yourself. Be an enemy of what you know, of what you've read. Alhazen, by the way, he came up with this because, a lot of people in those days, we're talking about the 10th century, 11th century, they simply read the Greeks. They had the Greek books, which they translated into Arabic. And they would just say, well, Aristotle said this and Plato said that. And this guy says, look, just be a skeptic of what the Greeks said. Try to think outside the box. Be a critic of what you read. Okay? And, this is the time to apply it. I'm going to give you a different theory, and obviously this means you're going to have to think outside the box. Move outside the box for a second at least to understand it. Whether you believe it or not is a separate issue. Okay, so let's start with Mr. Good old Newton and compare him against Bill Gates. Okay, that's Newton on the left, and that's Martin Luther Bill on the right. Did a little video on that, and maybe you should watch it. Anyways, what does Newton propose? He says that gravity is a force, okay? And what does that mean? He says that you have the gravitational constant G, that's a constant, so we can even remove it. But essentially, because, we're interested in understanding what's going on here from a physical point of view, from a mechanistic point of view, we're saying there's a mass 1, that's that object 1 on the left, the orange one. And you have a mass 2, that's the object on the right, the cylinder, the blue one, right? And if you want to do a calculation for force, you want to know what the magnitude of the force is, you got to divide it by distance squared. In other words, the distance that separates them. And I'm going to replace Newton's formula, the letter F, with the letter T. I'm going to say that what I'm going to argue today is that gravity is not a force. Gravity is a tension, and tension is not a force. Of course, a lot of the mathematicians out there will be horrified by what I'm saying. They've been taught that tension is a force, and I'm saying tension is not a force. That'll be the argument, okay? Okay, and as you can see, I put a bunch of lines connecting the two objects there. 4 of the atoms in one object to 4 of the atoms of the other. That's going to be essentially the mechanism. I'm going to say all the atoms are interconnected. Doesn't matter by what right now, I'm just saying they're physically interconnected. We just can't see the mediators. That's the only issue. But other than that, I'm going to make the assumption that all atoms are interconnected. And that would certainly explain what Mr. Muller said, that this atom is pulling on you and you're pulling on it. There you have it, right there. Every atom is interconnected. I think that part at least I can address, okay? Okay, so what's the issue here? Well, here we have the theory in a nutshell. If all atoms are interconnected, we have 2 objects, a cube or a box, whatever, on the left and a cylinder on the right. When they're far away from each other, all the ropes, which I'm going to be using here, the mediators, the interconnections, they all come together and act as if they were a single one. It's like a single coaxial. As the 2 objects approach each other, the ropes, in this case, right, the interconnection, the physical mediators, they branch out, they fan out. And the closer they come together, you see more fanning out of those connections. If every atom of one object is tied, is physically bound to every atom of the other object, this is what you would expect as 2 objects approach each other. At great distances, you have a single coaxial. All the interconnections come together and act as a single one. Therefore, gravity is weak. And as they approach each other, you can see that every interconnection here is acting independently. Okay? And that's why I'm saying that shorter the distances, the rope binding atoms of one object to the other fan out and act independently. The closer they are, the more atoms that step behind the one in front of it. Okay? And now you have a new atom that's acting independently because it's pulling at a different angle. And here's another version of this. Okay? Explains it in a little more detail, so if you bear with me, you'll probably understand what I'm saying here. I'm saying you have atom number 6, and it's in the same line as 1, 2, 3, 4, and 5. So all these atoms you can say are on the same axis, okay, at a certain distance. Did the cylinder change its weight, its mass? Did the box change its mass? No. The masses remain the same, but what happens as the cylinder approaches the box? Well, you can see now all these atoms are not on the same axis. Suddenly they are on different, in other words, they're acting independently. They're at different angles. It's like suddenly, out of nowhere, you created 4 atoms, number 2, 3, 4, and 5. In the first case, the one above, Number one was, it's like if number one was pulling on number six, and two, three, and four, and five were irrelevant because they were on the same line. And as the cylinder approaches the box, what happens is they go out of alignment. Now each one of those atoms, 2, 3, 4, and 5, are acting independently with respect to 6. Okay? So what we have here is a situation where, distance is the only factor. Okay? I hope that's understood. Two objects far apart, all the atoms are connected to each other. They're also connected within the objects, okay? But that's irrelevant for what we're saying here. We're trying to figure out how one object accelerates towards another, why there's an acceleration of gravity. You throw a pen or you let go of a pen, it falls to the floor. Why does it accelerate at 9.8 meters per second square here on Earth? On the moon, it goes slower, but, again, there's an acceleration. It goes faster the closer it gets to the center of gravity. And if every atom of the object that you're going to let go of is connected to every atom on Earth, as Mr. Muller says, every atom is pulling on you, and you're pulling on it. Every atom is pulling on every atom of the pen, and every atom of the pen is pulling on every atom of the Earth. That's a description of, every atom is interconnected. That's how else would you explain that? And, well, you might have a different version, but all I'm saying is I'm going to put an interconnection, a physical connector, and by that, I'm simulating the acceleration of gravity. So I don't think you can slap me in the face when I'm telling you that every atom is interconnected, and at least that explains the acceleration of gravity and explains why every atom of the pen pulls on every atom of the Earth and vice versa. Okay? Okay. Let's see. Let's explain a little bit about tension, okay? Because I'm going to say there's no force between any two atoms, okay? By the way, I'm going to argue that there's only tension, okay? And we'll get to that slowly, because I know this this goes over people's heads many times. So I'm going to try to go slowly just for your understanding, okay? Let's get that clear. Okay, here you have one fellow pulling against another fellow. Okay, they're tugging on 4 ropes. They're doing a tug of war, okay? And there's 3 other fellows that are just putting their hands on the 4 ropes. They're just laying their hands on the ropes. So they're not participating in the pull, okay? They just put their hands on the ropes. And the guy on the right is not pulling against 4 of them. He's only pulling against the first guy, or the last guy, I guess you could say, the one completely on the left. And the other 3 guys are just putting their hands on it. They do not intervene in the tug of war. They are not using any force, and neither is the guy on the right pulling against them. What happens when those 4 ropes are now connected to these guys, and they're all at a different angle? They're all pulling against this fellow. Well, now this fellow over here on the right, he's feeling the pull from these 4 guys. Okay? So in the first case is the case when 2 objects are very far apart, and the interconnections, which I'll refer to it as the rope. The ropes are all on the same axis. And so it's like the 3 guys there, which represent essentially 3 atoms, it's like they don't exist because they're on the same line. They're on the same axis. Only when the 2 objects, in this case, the guy on the right and the 4 guys on the left, come together, do the ropes separate simply because of a function of distance. Keep that in mind. The only thing that's happened here is the distance. No one has changed his mass. The 4 guys on the left, they weigh as much as they weighed before. The guy on the right also weighs as much as he did before. In other words, this is what we see with gravity. The objects don't change their mass. What they change is just the distance between them. How do you cause acceleration of gravity? Well, what's happening there is now you have a stronger tug from 4 guys on the bottom than you did when the 4 guys were on the top and 3 of them were just, putting their hands on the rope. Okay, so that's how distance affects the force of gravity. Okay, let's move to another. I try to make all these images to grab it from every possible angle. Okay, so here we see the same issue. The ones on the top, the 2 objects on the top, the box and the cylinder, they're very far apart, and so all these ropes, they act as a single one. As far as they're concerned, there's a single coaxial uniting these 2 objects. What happens as the objects approach each other? They come together. Okay, the distance between them decreases. Well, you can see what's happening as you go downwards and the objects come closer to each other. What's happening is the ropes start fanning out because every atom is at a different angle with respect to every atom of the other object. Okay? And so what's happening is all you have is more ropes acting independently at different angles. That's the idea. That's the theory, okay? That's what I'm trying to show. And here's the dynamic version of that, okay? Okay, I hope you understand what I'm showing there. I'm showing that as the 2 objects come together, the atoms are pulling on the atoms of the other object at different angles. That means that every rope is acting independently, whereas when they were far away, they were all superimposed. That's what I'm trying to show there. Okay, that's the mechanism I'm proposing for the acceleration of gravity. Okay. I don't know if this is beyond your grasp. I hope it's simple. 2 objects, they're far apart. All the ropes superimposed, they act as one. Gravity is weak. As they come together, for whatever reason, okay, as they come together, they approach each other, the ropes start fanning out. Why do they fan out? Because now the atoms over here are not aligned on the same, they're not on the same line as they were before when they were far away. As they come together, the ropes connecting one atom over here to the atom over here, they start spreading out. And so each rope acts independently, okay? And I'm saying that it's the quantity of ropes that act as 2 objects change the distance between them that produces this acceleration of gravity. And of course, that is exponential. That explains the distance squared factor in Newton's equation. And so far we can explain that, and we can also explain that why, every atom on Earth is pulling on every atom of you, and you're pulling on it, okay? Now, is there a pull? Are we saying that one atom pulls on another atom? The answer is no. Okay? Do the ropes stretch? No. So the ropes don't stretch, and there is no pulling of one atom on another. There is no pull. There is tension, and tension is not a pull, tension is not a force. There are only 2 forces in the universe that we can, there are only 2 forms of contact we can imagine, push and pull, okay, for something to move. Tension is when no one wins the tug of war. That's why tension is not a force. Force, mass, times acceleration. Acceleration means you're going in one direction or another. Whether push or pull, it doesn't matter, but you're moving in one direction or another. Someone wins the tug of war. Tension, no one wins the tug of war. It's a tied game. And let me illustrate that so that you know what I'm talking about in case you can't visualize it. Here it is. This is all we have in the universe. We have 2 balls. I made them both red and equal just so that we don't have, you want them yellow, I'll put them yellow, no problem. Okay, we have 2 balls. They're interconnected by something. We'll call it a something. Okay, it could be a stick, it could be a rubber band, it could be an elastic band, whatever you want to put in there. A piece of cloth, a rope, a string, wire. Okay? Now, this is all there is in the universe. Okay? I want you to focus on it. This is all there is in the universe. Okay? Does anyone win the tug of war? Is there any tug of war going on here? Or is there just tension? Okay? They just sit there forever. Well, let's put them in motion. Let's see what happens when we put them in motion. Okay? Here they go in motion. Okay, again, this is all there is in the universe, okay? There's nothing else. No matter, no ether, no anything. All we have is empty space, vacuum, nothingness. We have two objects. They're tied by some kind of entity, string, whatever you want to call that. They're rotating. Does anyone win the tug of war? If they both have the same, oh, by the way, they're made of a single piece. That means these are not made of particles. This is the only particle. Okay, so each one of these particles is made of a single piece. It's not made of components. Okay, so does anyone win the tug of war? If they weigh the same thing, they have the same mass, they're rotating, does anyone pull on the other guy? Well, no. Rationality would tell you that no, that no one wins this tug of war. Okay, it's a tied game. What you have is tension across that string or across that thing that unites them. All you have is tension. There is no force here, no force on the string, no force of one object on the other, because no one wins the tug of war. I mean, if suddenly they were to move in one direction or the other, then you'd say, oh, something's going on because, suddenly one of the objects is stronger than the other guy for whatever reason, weighs more or whatever. And if they're both exactly the same, then there should be no force. All you have is tension. And I'm saying that that's what happens under the rope model between any two atoms. All you have is tension. We have to assume that each one of these systems is like it's the only two objects in the universe. Okay, so no one wins the tug of war between any two atoms. In fact, it has to be so under the rope model. Okay, it has to be so because we're not going to produce gravity by pulling on the rope. Okay, we're not going to stretch the rope. We're not going to have more strength of one hydrogen atom over another. No, it's not going to be done by pulling. The way it's going to be done is by aggregation. Remember what the mechanism is. The mechanism is you have two objects far away, all the ropes come together. They superimpose, they pull on the same axis as if they were a single one. When they approach each other, the ropes fan out, and it's going to be the distance that determines what the force of gravity is. The masses have not changed their values. They have not, one mass has not gone up because, the two objects approach each other. The two masses remain with the same mass. The two objects remain with the same mass, the same weight, the same kilograms. All you have is just, distance changing between them. That's all. And the only way you can show this, the only way you can mimic this is by saying what Richard Muller says. Every atom is pulling on another one, and the other one is pulling on this one. They're actually not pulling. There's tension between them, and all we have is distance changing between them. And it's the aggregate of ropes, in other words, of independent ropes that are now pulling at a different angle that causes the acceleration of gravity. That's the proposal. Okay? I hope I'm getting through to someone at least out there. I hope you understand what I'm proposing, okay? So that at least you don't say like this fellow, how do you pull? And your theory stinks, but I don't know how you produce pull if you tie a television set to a table. Yeah, because there is no pull. It's tension, and it's tension from every atom. By changing the distance, that's when you have the acceleration. That's when you have the so-called pull of gravity. Okay, let's put it in motion so that you can visualize the difference between Newton force and Bill Gates tension. Okay, there's a difference there. And we're going to have math, Newton, against physics, Bill. Okay, so we got a difference here because Newton just described it mathematically and says, look, I don't understand it. He says, fingo non hypothesis. I have no hypothesis, meaning he had no theory. He had no explanation for his equation. I have the explanation, and in order to do that, I'm saying we have to replace the word force with the word tension. Tension is not a force. Force is someone accelerates towards the other. Tension, no one wins the tug of war. For each solution per distance. At a given distance, you have only one solution. At that point, there's only tension. Only when you set that in motion at different distances do you get this force. But just for one solution, okay, of Newton's equation, you only get one value. That value is not representative of force because there is no motion at that point in time. It's mass divided by the distance that separates them. Where's the force? There's no motion. You're looking at a picture. You're looking at a static image. And that's what I want to show now. So let's see if I can find it here. There it is. Look at this carefully, okay? I'm going to run it several times. Okay? What we have here is the mathematical version. Here we have Newton, and he says force equal gravitational constant times all that. We get rid of the gravitational constant. We don't need it for our explanation here. Essentially what Newton does, he weighs a box and says 10 kilograms. He weighs a cylinder and he has his second mass. And then how does he do distance? That's where the critical part is. Well, in mathematical physics, what they do is they unroll the end of the measuring tape, or they count tiles. And that's where they differ from physics. That's not distance. That's distance traveled. And it's distance traveled and not distance. The way they do it in mathematics is they say, look, we take the tape, measuring tape, and we unroll it. We're unrolling the end of the measuring tape, and we measure 1 meter. Or we measure we measure one tile, and we say, well, this tile measures 1 meter. So what is the length of the room? What is the distance from wall to wall? Well, let me put tiles in between the two walls and tell you. So I put 10 tiles, and I say it's 10 meters. So what I have is distance traveled. What I've done is put one tile after another, counted the tiles, and say, look, the distance between this is 10 meters. What is 10 meters? It's the distance traveled. Okay, that's what the little man there is doing. He's putting tiles, and he's counting the number of tiles. That's the way they do it in mathematics. And that's why they end up with force. Okay, because Newton saw this as a dynamic equation. He says the distance changes. It does, but it changes from, it changes when you look at when you plot all the points. That's when it changes. The distance changes as time goes by. For every solution for this equation, you only get one value. And that value is just the distance between the two masses, the two objects that you have there. Okay? So look at it carefully because I'm going to change it now in a second. I'm going to show you the physics version of this. This is the version of the religion of mathematical physics. This is what you learn in high school. This is what you learn in college. You just put a mass, a value for the mass. How did they determine the mass? They weighed the object and they said, well, it measures 10 kilograms. How about the other one? Well, the other one's 11 kilograms. And what about the distance? Well, let me measure it. And so you unroll the tape from wall to wall and you say, well, it's 10 meters. Or perhaps you measure one tile and say, that's going to be my standard. Okay, how much does your tile, what is the length of your tile? It's 1 meter. Okay, so what's the distance from wall to wall? Well, let me put some tiles there for you. 10 tiles, okay, it's 10 meters. So this is all numbers. Okay, these are all numbers. That's the mathematical version. You still have no idea what's causing the force, what the mechanism is, and that's why Newton could not say, what the mechanism is. He had no hypothesis. Okay, now let's do physics for a change. Let's get rid of math and let's do some real physics. Okay, here's Bill's version. It's under the rope model. We have tension. Do we weigh the box? No, we put it up there. Do we weigh the cylinder? No, we replace the mass with the object. We have two objects. Do we have distance measured? No. We simply have distance, qualitative distance between two objects. As they come together, you see what's happening not with the objects, what's happening with the ropes that interconnect every one of the atoms. So we replace mass 1 with what? With a value? No, we put an object there. We don't care what the mass is. We just put an object that's got so many atoms. We put another object that's got so many atoms. And then all we look at is the separation between them. Qualitative separation, distance. That's the distance of physics, just separation. Mother Nature, she doesn't know what 10 meters is. Mother Nature doesn't know what a kilogram is. Mother Nature can tell you how many atoms an object has. You know, she knows that exactly. And she can tell you what the separation, the qualitative separation is between two objects. That she understands. So how does she do her magic? Well, you got to look at the invisible stuff between the two objects. What you have there is these invisible connections. We'll call them ropes. And as the objects come together, the ropes fan out. Every atom of one object is pulling on every atom of the other object. As they get closer together, what is happening is the angles change, and so the ropes are no longer superimposed as they were when they were far away. And this is the mechanism of gravity. It's the mechanism of the acceleration of gravity of one object with respect to another. Okay? Okay. Did I convince you? Well, I'm not here to convince you. I'm not here to persuade you. I'm not here to twist your arm. I'm here to get you to understand the theory, so at least that you don't put words in my mouth or tell me, well, I didn't understand how an object pulls on another, but I hate your theory. You know, that's not very profitable for anyone. This guy just wastes his time writing paragraphs, and you say, don't you have something better to do with your time? I mean, if you come over, at least learn, what the mechanism is. Then you can say, well, look, this is where I think you're wrong, or this is where you're irrational, or this is where your theory fails, or whatever, But you say, I don't understand how an object pulls on another with ropes, because, when I tie my television set to a chair, it doesn't pull it. So I think your theory is ridiculous. Well, yeah, if that were my theory, it would be ridiculous. But it shows that the person didn't even make the minimum effort of understanding the theory. That's why I'm trying to explain the theory so people don't put words in my mouth. Doesn't mean you have to believe my theory. I'm just asking you to understand it. Okay? And what I'm saying is you have two objects. All atoms are interconnected between them, and explains what Richard Muller said, that every atom on Earth is pulling on every atom of you, and you're pulling on every atom of the Earth. If every atom is connected by a rope, that explains that aspect of it, no doubt about it. Now, that's the way I look at it. Maybe you have a different interpretation, that's fine. And that's where your criticism should come, where that fails. Okay? That's the first part. Second part is I can explain the acceleration of gravity because, if these connections superimpose because the two objects are very far away from each other, well, they'll pull as a single coaxial, and obviously gravity will be weak. It's only when they approach each other that the ropes fan out, right? And the nearer they get, the faster they go. Why? Because, the ropes, every rope is now at a different angle with respect to the other object, and they have to pull at increasing speeds. That means there is an acceleration there, and that acceleration has to be square of the distance. Or something similar to that at least, right? And so I can explain the acceleration of gravity. I can explain why every atom of you pulls on every atom of the Earth. And then you have the issue that, that I'm saying that there is no pull between two atoms. One atom does not pull on another atom, because if you only have two atoms in the entire universe, connected by a rope or by whatever, it doesn't really matter. If those two atoms are exactly the same, they're two hydrogen atoms, they're exactly the same from every point of view except location, right? One's on the other side of the other. No one wins the tug of war. You could not justify logically why one atom wins the tug of war, even when they're spinning or just standing still. Either way, you cannot justify anything other than tension on that rope, on that thing that connects them. And the only way you're going to get force instead of tension is through aggregation. And that means that, every rope aggregating to the total as two objects come together. Now, some people immediately ask the question. They say, well, what are these ropes? And how much do they weigh? How long do they stretch? And how do they avoid tangling? And, they have all these questions. And we have to start at the beginning. We have to start at square one. The first question the person has to answer is, does the model that I just described and explained, does that explain gravity? They explain why one atom, all atoms of you pull on the earth. Does it answer all these questions? Because if you decide that it doesn't, that what I just explained does not explain gravity, there's no reason to tell you, or there's no reason for me to even spend any time on trying to answer, what are these ropes, what are they made of, how long are they, and how much do they weigh? I don't have to answer any of those questions because we're on record saying that, the model that I presented does not explain gravity. So you first have to cover that base. You got to say, look, does it explain gravity or doesn't it? That's the first part, before you can ask any question. So you got to concede that or fight it, one of the two, okay? And so the smart aleck comes around and he says, well, Bill, I can do it with angels. I can do it with spirits. Okay, I don't even have to hear it. I'll concede it. Okay, so you can do it with angels, you can do it with spirits, and you can do it with ropes. You cannot do it with particles, you cannot do it with transverse waves, you cannot do it with quantum mechanics. That's the issue. And that's the second issue we have to cover. Okay? Because quantum is on record saying you cannot explain gravity. No one can understand how this universe works. They cannot do it with particles. You cannot throw particles at another object and pull it. You cannot throw transverse waves, one-directional transverse waves, to another object and pull it. And so you cannot explain it with particles or transverse waves. Now, some bright people out there, you know what I mean? Some bright, very bright people, they're just, they start out with pressure. They say there's pressure in the universe. They got all these particles out there. Usually they do it with particles, right? They're particle men. They have this ether out there, an ocean of ether covering everywhere. And they start out with pressure. And they say there's just pressure. Everything's under pressure, right? Everything in the universe is under pressure. Even things on the edge of the universe, that's under pressure too. Or they make the universe, this ether or whatever, infinite so that they don't have to answer the question. So they have this pressure. And so why does, when I let go of the pen, right, it falls to the floor? Well, because you were holding it against the pressure pushing it down, right? And as soon as you let go, the pressure pushes it down. It's a push gravity mechanism. These bright people, they come up with these solutions. They're bright. They're so intelligent that's just scary. And then the issue is, why did the pen fall to the center of the earth? Why didn't the pressure push it upwards, away from the earth? Why would the pressure go towards the center of the earth? Maybe gravity pulls it there? All the particles of the ether pushing inwards towards the center of the earth, so anything you let go of, it goes to the center of the earth. Why? Because all the pressure is towards the center of the earth. Why that would be so, I don't know, and that's what they would have to explain. But the point here is you cannot explain gravity rationally, okay? All these loonies out there, they can say whatever they want. But you cannot explain gravity with particles or with waves. That's the issue. And if you cannot explain with gravity or gravity with either particles or waves, quantum dies. Okay? Can you explain with space-time? Well, we got to find out what space-time is, you know? I mean, and that's a can of worms, because here you have a concept turned into an object. And again, it'll tell you that you cannot imagine four-dimensional space-time, and you know they go through this whole rigmarole that everybody pretty much that has some exposure to it, you know, understands pretty much that they cannot explain it. So yes, you can do it with angels, you can do it with spirits, and you can do it with ropes. You cannot do it with particles, you cannot do it with waves, and you cannot do it with space-time, physically, mechanically. Okay. And so, you know, you cannot do gravity with quantum or relativity. And that's the issue. So what are the questions? The questions are, before you ask, what are these ropes? What are they made of? How much do they weigh? How do they avoid tangling? Blah, 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 blah. Does the mechanism I just explained explain gravity? Is it the mechanism of gravity? If it doesn't, you know, there's no need for me to answer any question, because obviously the mechanism doesn't work. If it does work, the second question you got to answer is, can quantum mechanics or general relativity explain the same gravity in a mechanistic way? Can it tell you how one atom pulls on the earth and the atom pulls on the atom, on every atom of you? Can it explain that phenomenon? And if it can't, then let's first get rid of quantum. Let's first get rid of general relativity before we go deeper into questions on the rope model. That's the issue. And with that, I'll see you on Wednesday, and we'll continue with some of the other questions and comments that some people have put out there. We'll see you then. Bye-bye.